Alrighty, so today we're going to be looking at doing what we've done in the past two lessons, but this time we're going to do it algebraically. So we're going to look at, do we have the techniques and the skills to actually do this? And the answer is we actually have all the skills we need. We just need to remember a little bit of substitution, and then we need to remember how to factorize. Alrighty, so using the fact that this is y equals and the fact that this is y equals is a perfect substitution thing. Elimination, I could technically do elimination. It's going to do basically the same thing, but I think this is a perfect example where substitution works great. So let's sub 1 into 2. So that means we're subbing into 2, so 2 is y is equal to 3x minus 2, and I want to replace y with equation 1. So there we go, I've done my substitution. Step 2, move all of the variables to one side so that I've got 0 on one side and the other. So I'm going to move both of these guys over to the other side. So that means I'm going to be subtracting 3x from both sides. And I'm also going to be adding 2 to both sides just to get a nice good old 0 on the right hand side. And on the left side, I'm left with negative 20, negative 19x, 2x squared, and x to the 3. And now what I really want to do is factorize this thing on the left. And the thing on the left is just a cubic, and I know how to factorize a cubic. I may not enjoy doing it, but it's doable. I just need to guess what I think the potential options are. And looking at the negative 20, it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. And so those are my different options. Now, fingers crossed, it's going to be 1 or negative 1, or maybe 2 or negative 2, but hopefully I don't have to guess too much. So let's try x equals 1. See if that's a solution. So we get 1 to the 3 plus 2x, 2 times 1 squared minus 19 times 1 minus 20. And we just want to see whether that's actually 0. So that's 1 plus 2 minus 19, okay, so that's definitely not equal to 0. So let's try x equals negative 1. See if that's any better. Alrighty, so we get negative 1 to the 3 plus 2 times negative 1 squared minus 19 times negative 1 minus 20. And what's this equal to? Well, it's minus 1, and negative 1 squared times 2 is 2. And we get plus 19 minus 20. Well, it's going to be close, but it looks like it just works. We get negative 21, positive 21, which all cancels out, which is equal to 0. Okay, therefore, x equals negative 1. Well, that means x plus 1 must be a factor. So we found our factor. Now we need to divide that by the factor we've just found. Long division time. So x plus 1, x to the 3 plus 2x squared minus 19x minus 20. Alrighty, time to do some division. Alrighty, so to make x looks like x to the 3, I'm going to multiply it by x squared. Expand out the brackets, I get x to the 3 plus x squared. Now I do my subtraction. X to the 3 minus x to the 3 is nothing. 2x squared minus x squared is x squared. Bring the 19 down. Alrighty, new game. How do I make x look like x squared? Well, multiply it by x. Do the subtraction. Alrighty. X squared minus x squared is 0. Negative 19 minus x is negative 20x. Bring the negative 20 down. And hey, look, this is looking really likely. Why? Because how do I make x look like negative 20x? We'll multiply it by negative 20. Expand those brackets out. subtract off, and we're left with 0 plus 0. Perfect. We're happy. Therefore, this is really x plus 1, x to the 3 plus 2x squared minus 19x minus 20. And we know that it's equal to 0 from what we worked out way earlier back up here. All right, so we factored out one bit. Now we need to continue going. Oh, no, sorry, what have I put in there? That's the wrong thing. In the brackets, I want to put x squared plus x minus 20. Alrighty, well, I've now got a linear times a quadratic. Let's factorize this fella. So teacher, something to multiply to negative 20, but adds to 1. Can't be 20 and negative 1. It can't be 10 and negative 2. It has to be 5 and negative 4. And it is a monic. There's a 1 here, which means that I can directly factorize it. X plus 1, x minus 4, x plus 5 equals 0. And now I've got my three solutions. So x1 is equal to negative 1, x2 is equal to positive 4, and x3 is equal to negative 5. But like I said at the beginning, I'm not interested in just the x-coordinate. I also want to know what the y-coordinate is. So let's substitute these back in. Now the question is, does it matter which do I substitute it into? Do I substitute it into equation 1 or equation 2? Well, the whole point of them being simultaneous solutions is that they should not only have the same x-coordinate, but they should also have the same y-coordinate. So I'm going to sub them both into y. So the second function, so 3x minus 2. So let's do that. So y is equal to 3x. Take 2. Sub in x1 equals negative 1. Y is equal to 3 times negative 1 minus 2. Negative 3 minus 2 is negative 5. So my first solution should be negative 1, negative 5. My next solution, x2 is equal to 4. Y is equal to 3 times 4 minus 2. 12 minus 2 is 10. So my second point should be 4, 10. And my last solution, based on x3, I get y is equal to 3 times negative 5 minus 2, negative 17, negative 5, negative 17. Now, obviously in an exam we can't use this, but for today, why not use some Desmos to double check? So let's start off by just typing in the two functions. So if y is equal to 3x minus 2, and the second function was y is equal to x to the power of 3 plus 2x squared minus 16x minus 22. And we can see this is the picture we actually get. Let me move this across a little bit so we can actually have a look. And we can see that there looks like there's three solutions. 1, 2, and 3, which perfectly match the three solutions that we found algebraically. 4, 10, negative 1. Ooh. Yep, and so there are the three solutions, all on the one picture, and they absolutely match the three ones we found. Alrighty, so that is how you can complete simultaneous equations. Step 1, you substitute it in, you rearrange it so it's a cubic, and then we just factorize it like it was a cubic. Alrighty, I'll see you in the next one. Goodbye.